We continue with events. The next concept between events is unions and intersections. So once again, we will illustrate these concepts using examples. So intersection of events is intersection of two events is the set of all outcomes that are common to both events. So like the diagram that we saw previously. So here, this is event A, this is event B. Now this intersection, so that's the set that is common to both A and B. A and B. So it is that those outcomes are part of A as well as B. So that's called intersection. So we'll illustrate that with an example, our familiar example of drawing one single card from a deck of 52. Okay. So now how many possibilities are there in the sample space? N is equal to 52. All right. So now let's define an event, draw 7. So what is the probability of drawing a 7? So we need to find K, and that is how many of the outcomes in the sample space satisfies the definition of the event drawing 7. Since there are 4 cards, 7, this K is 4. So now the probability of drawing a 7 is that divided by that. Okay, and I'm going to make that C12 absolute, so we will be able to copy this probability down with the n always coming from C12. And let's format this. Okay. Now let's define another event, event B, that is draw a heart. Now what is the probability of that? Okay, we need to now know how many outcomes in the sample space satisfy this condition of being a hot card, and out of the 52 there are 13 of them that are hot cards. So since we took this cell and divided by that cell, with that cell being an absolute address, we will be able to simply copy that and we will have the probability of B. Now what is the intersection of A and B? So we are now looking at intersection of events. So how many outcomes are there in the intersection of these two events? So being a 7 as well as being a heart, there is only one of those. So the probability of intersection is that. Now what about union of events? Okay, that's the second concept. Union of event is a collection of all of the outcomes that are either in A or in B. So when this is the intersection, the collective, the whole thing, okay, like that, that would be our union. Okay, so let's again continue with the same example. Event A is draw a 7, and the probability comes, that's the same as there. So I'm going to just use the value from the previous example, so you don't have to set everything up then one more time. So, and then event B is again draw a heart, and that probability is that. Now we want union of A and B. So that would be all hearts, okay, which includes the 7, okay, and then the 3 other 7s which are not hearts. So that would be the union of A and B. So how many outcomes are there like that? There is 13, the heart cards, and of these 4, one of those is already counted in 13. So there is 3 remaining. That's total of 16. So now the probability here is, I can't copy this down because this one refers back to that. So I have to go that divided by that. So that will give me the probability of the union of A and B, or A union B. Now we can develop some probability rules for the intersection, union, and conditional probability. We haven't talked about conditional probabilities yet. We'll come to that in just a second. Now here are some notations that we need to be familiar with. Intersection of events A and B can also be written as A and B, or A upside down, kind of a U, it's kind of a odd size U, or simply AB. So then we can write probability of A and B, intersection of A and B would be probability of A and B, or probability of A upside down U B, or probability of just AB. So these are the notations we use for intersection. And for union, you can represent union of A and B as A or B, or A with a U and B. So probability of the union will be written in this fashion. Okay, the rule for probability of union is easily understood. That is, when you take probability of A, you add probability of B to it. So when you do that, what happens is this part gets double counted. Once with A, and once again when we add B to it. So we have to take one of those two double counts out. So then we get like that probability. So that's the probability rule. Let's apply this rule to the probabilities A and B here. Probability of A from our example is A is draw event A is that, so that is probability of A. Now probability of B is this, right? And probability of intersection is that. So we have already computed this using basic principles. Okay. Now let's apply this rule and verify that it will be equal to this probability. Okay. So probability of union is probability of A plus probability of B minus probability of the intersection of A and B, and that is exactly same as what we got previously.